Okay, so here's the tangent line. It's simple. We've got the point 0, 10. And the derivative at this point 0, 10. At the point is 0, 10. T is 0, y is 10. So the slope at time equals 0 is -0.02 times 100 to -2. It's cruel, right? Because you're used to this letter being the number you put the x value in. So for A, we've got y is y, right? Minus 10 equals t negative 2t. And we want to find y, y2. Right? B, using the given differential equation, determine whether the graph shown whether the graph of f could resemble the graph shown. And since dy dt is greater than or equal to 0, all t the graph of f must always be decreasing. So the graph shown cannot be the graph of f. Good? Find an expression for y equals f of x by solving the differential equation with the initial condition. So let's see. Now, this 0.02 does not move. Y squared moves. 0.02, negative 0.02 does not move. So I have y to the negative 2 y equals negative 0.02 t. That's separating the variables correctly. Okay? Integrate both sides. Be careful. The integral of 1 over y squared is not natural log of y squared. You add 1 to the power and divide by the new power, which you can do with negative 2. You add 1 to negative 2 and divide by negative 2, you just get negative 1 over y, or negative y to negative 1. Okay? And then we use the initial condition 0, 10. This is negative 1/10 equals C. plug C in. And solve for y. Right, change all the signs. Flip both sides. Okay? This is a cruel one as well. Tell whether the amount of the substance is changing at an increasing or decreasing rates. So we want the rate of change of the rate of change. So we have to take the derivative of this. And that's that. Which is since why is it positive? The substance is changing.
Why did you substitute negative 0.02 dyt for dyt?
Oh, it's y squared. Thank you. I could not figure that out. Well, you can't have negative grams of something. Substance is changing at an increasing rate. Good, that'll do. Okay? We've got 6 grams for the approximation, 2 points, 1 point for finding the derivative at 0 is -2, with the slope 1 point for getting the answer. I don't think I put grams down. Probably, possibly a problem. Since this is always negative, it says the graph of f is non-increasing. Because it could be 0. Find the expression with the initial condition. Oh, this is exactly what we had. 4 points for that. Usually more than this last one. This negative thing times that negative thing is this positive thing. Because y is always positive, this second derivative is always positive. The amount of the substance is changing at an increasing rate. Good? And the last one? So we had to show by using implicit differentiation. So 2 minus 2 prime equals negative sine of y prime. Whoa. That should get us there. Probably a point for the derivative. They're both negative, aren't they? Everything's negative. That's up. I think I'm okay still. Right. This is no calculator. What's y? 0. Right? To make this equal 1, y, sine of y has to be 0. What do we have to do? We've got right, so we knew y was 0, so we can solve for x by using the original equation. If y is 0, cosine of 0 is 1. X is 2. Determine the concavity. And then we take the derivative. That's the way I do it. Use the chain rule. So it's -2. The -2 power times the derivative of what's inside. Derivative of negative sine is negative cosine of y and y prime. Y prime is this. Gosh, it's a mess. That is times y prime. It's always positive. The denominator is always positive. Because sine of y can't ever be bigger than 1. So 2 minus something smaller than 1 is going to be positive. Cosine between negative pi over 2 and pi over 2 is always positive. Not including the endpoints. Because it's the x-coordinate on the unit circle. Good? I'm just going to show you this answer. I don't think I can rewrite it. I'm serious. Did you do it? Yeah, I can't do it. guys won't believe it, actually. Well, let's check everything else. Right? Implicit differentiation, so 1 point for this next step. And then 1 point for the final verification, solving for dy dx. Everything's the same, right? If we set this equal to 1, sine of y is 0, y has to be 0. Plug 0 in, solve for x, get 2, and it's 0.20. Second derivative is that. Kind of a mess. Did it make sense when I did it? Denominator is always positive since sine can't be big enough. Numerator is always positive because cosine on this interval is always positive. So it's kind of came up. All they said was d squared y dx squared is positive on the interval. And then this mess. I don't know how this is turned into that. I don't know. These two, I don't know. I can't explain it. I would not get anything on those. I lose those 2 points. No problem. Is that the last thing? Okay. Do you guys have anything specific you want to look at? Okay. Yeah, I'm not sure those flashcards are helping either. So if you're looking at the flashcards on the paper, this is the best form for those. Okay, here they are. So Rolle's theorem is the mean value theorem. Rolle's theorem, I'm at 15 minutes. Is this what you're talking about? Rolle's theorem is the mean value theorem. So Rolle's theorem says f of A and f of B are equal. Those are two y values and two different x values. It says f of A and f of B are equal. So if you have a continuous and differentiable function, a smooth function that goes through those 2 points, they either have to go through like that or like that, right? In either case, you're guaranteed, kind of like by the mean value theorem, that there's at least 1 point in between A and B that there's a horizontal tangent. That's what Rolle's theorem says. Okay? Mean value theorem says the same thing, but it doesn't say A and B have the same y values. A and B can have different y values. differential. So you can't draw a curve unless the calibration's off. You cannot draw a curve, so flippin' funny, between those 2 points without having a tangent equal to the secant. The slope of the tangent equal to the slope of the secant. Like the slope of the secant is this slope, whatever the rise and run is. But if you draw a smooth curve between those 2 points, you're guaranteed a spot in between A and B that has the same slope as the average rate of change. This is the slope of the secant. Okay? So the mean value theorem says instantaneous rate of change, that's slope of the tangent line, equals the average rate of change. That's the slope of the secant line. Okay? Does that make sense? And this shows up where they say, are you guaranteed between A and B to have a slope that's equal to the secant? It'll ask you specifically, so you know it's the mean value theorem. So what you do for your response is you check to see if it's continuous and differentiable. If it is, then yes. And if it's not, then no. No, the function's not continuous, so no, it's not guaranteed by the mean value theorem. Yes, by the mean value theorem, it is guaranteed because it's continuous and differentiable. Right? Does that make sense? So that's how to answer that question, the mean value theorem specifically. The conditions of the mean value theorem are that the function is continuous and differentiable. Same as Rolle's theorem. It's not that way with the extreme value theorem. It just has to be continuous. But you need a closed interval for the extreme value theorem. Okay? The extreme value theorem says you have a continuous function on a closed interval. You're guaranteed an absolute maximum on that interval. The way you don't have an absolute maximum is you have an open interval, right? There's no absolute maximum because you can always get a little bit higher, closer to that y value where it's undefined. But if it's a closed interval, you're guaranteed an absolute maximum. Extreme value theorem. F is continuous in a closed interval. Those are the conditions of the extreme value theorem. Then we must both have an absolute maximum and an absolute minimum on the interval. Like, duh. Right? Of course you do. Doesn't matter what the function looks like. If you have closed interval, it doesn't end with an open circle on the end of it. You're going to have an absolute maximum and an absolute minimum. I can't. Okay. There. Now it has neither an absolute max or min, because it's an open interval. Intermediate value theorem says you have a continuous function, and that's all you need. And the y value for A is f of A, which is like less than y value for B, or greater, it's, whichever it is. Here's B, the y value here is f of B. Okay? These are y values, like 2 and 12. The intermediate value theorem guarantees there's a spot in between A and B where the y value is anything between 2 and 12. 7. Guaranteed. As long as the function's continuous, you cannot draw a curve from here to there without crossing the horizontal line y equals 7. Because it's continuous. If you're going from here to here, you must cross y equals 7. Of course, it could be 6 or 5 or 4, whatever is between 2 and 12. That's the intermediate value theorem. Like, duh. These are absolutely obvious. If the function is continuous, it's going to go and it touches the y value of 2 and the y value of 12. It's going to go through all those other y values to get to the 12. It could go way up to 100, but it's going to go back down to 12 because the y value rate B is 12. but if it goes to 100, it still has to pass that horizontal line 7. Does that explain them?
Yeah.
And how to use them. F must take on every y value between f of a and f of b. So these are y values, 2 and 12. No. Yes. If a function is differentiable at a point, it must be continuous at that point. Yeah. Four ways in which a function is not differentiable. It's discontinuous. Corner. A cusp is infinite slope on both sides. Right? A vertical tangent is this one. It's not differentiable there. A critical number are where you could potentially have max or mins. Those are where the slope of the tangent line is 0 or undefined. First derivative is positive, f is increasing. We know these well, right? First derivative is negative, f is decreasing. Are there any other ones that were funky? Do you see how I added one at the end? Oh, it's not here. But on the ones that you have, it was how to find the position. Because I don't like the way they have the position. They said the position function, and it pretty much is. Did I? Thanks. It's the one where the absolute value because it has total distance. They pass it again. No, there it is right there. Well, anyway, displacement of a particle is the integral, the rate of change over some interval. If we want the position, we need to see, we need to know where it starts. So we need to know S of A, and then we integrate from A to B. So we can find the position at B by starting where we know it is at A, and then integrate from A to B, and that'll give us the position at B. But we need to know where we start. The total distance is the integral of the absolute value of the velocity. So we don't need to know where it starts. So we just want to know how far it's gone. I added this. Do I have it someplace? Yeah, I do. So these are the nicest ones, like if you don't have flashcards, if you do have full sheets of paper, use this to help. Although we don't have shells, that's not a thing, so you don't need to know what a parashell is. It used to be a topic on the AB exam, but it's not anymore. You only have rectangles perpendicular to the axis of revolution for your exam. It's harder to look at these back-to-back ones if it's not cut out. Right? Anyway, I added this. Position of anything given an initial position and a rate of change is the initial, the final position is the initial position plus the integral of the rate of change. And it does not have to be a velocity, it could just be, could be the number of bottles if the rate of change is the rate of change, the machine that's making bottles. It could be the total number of people in line waiting, waiting to go on a roller coaster, right? You need to know how many you start with, and then integrate the rate at which people are joining and leaving, and that'll give you the total number of people in line. But this is hard to read because this one is the backside of that one. This one is the backside of this one. So it's harder to read. So when we get close, I'll do just around the edge. Yeah, remember doing this review packet? If you're feeling nervous about it, go over the review packet. And make sure you understand how to do all of it. It is, by the way, available to you, AP Exam Resources. Complete review of AP Calculus AD. It's the first thing we did after we finished learning everything, is I reviewed everything with you. And this is an incredible review of everything you need to know. This is the full review YouTube playlist. I go over all the problems. And I do like the typical thing where I say the answer and then write the wrong number. I do that a couple of times, of course, because I'm me. But pretty much explains everything you need to know in calculus. Semester 2 final exam. This is your final exam review that we're going to do. Like, you're going to take your final exam, I'm going to give you a review packet, and that's this. So I got a mask on. I have a problem number 15, of course, right? All free response questions. So this is all the free response questions, probably not all, probably through 2022 or something. 2023, that's pretty good. So if you need like something to do, you can choose any of these and look up the answers, just Google it, you'll get any of the answers you need. These are selected free response problems, and it tells you which one it is so you can look it up, and then I go over it. Okay. Here's some multiple choice questions that I go over as well. This was a released exam, the 2012 exam was released so we could use those in class. And I go over how to do each one. Multiple choice questions are good to go over because there's a lot of topics in a short amount of time. The free response is like one topic, 15 minutes to do. Multiple choices, you can go through 6 topics in the same 15 minutes. Anything else you have questions with or want to go over? Okay, so you guys know where to find those
study for the AD exam resources.